Hi everyone, and welcome to today's webinar, Top 6 Misconceptions about Linux Containers. Before we get started with today's presentation, there are a few items to quickly mention. You should see a taskbar at the bottom of your screen. Each icon is assigned to a particular element of today's webinar. If you're not sure what the icon does, hover over the icon with your mouse and a box will appear to tell you the function. Also, below the slides window you should see a blank Ask a Question box that allows you to type a question. After you type the question, click Submit to send it to our presenter. Feel free to submit your questions throughout the webinar, and our presenters will address as many as possible following the presentation. You can submit any technical questions related to the webinar platform here. Please close down other browser windows or applications that might be splitting your bandwidth, including VPNs, as these might interfere with the audio or video stream. If you experience any connectivity issues, please refresh your browser. Today's session is being recorded, and all registrants will receive an email within 1 to 2 days of the event with a link to view this presentation on demand. So now I'm going to hand it over to today's speakers, Red Hat's Mark Hagen and Cisco's Howie Zhu.
Thanks, Nick. Thanks, everyone, for joining from either this morning or this afternoon or whatever time zone you're in. We appreciate you taking the time to spend an hour with Red Hat and Cisco to hear about Linux containers and some of the details and our vision around it. So I'd like to start by talking about the current challenges that face the IT organization. Namely, you see on the slide sort of the conundrum that exists. You have the line of business driving very quick, fast, agile requirements into the development team saying, I need applications quick, new functionality quick, responding to changing market conditions very quick. But at the same time, you have the operations team who is really incented around keeping secure, stable platforms running and addressing things like regulatory compliance and security. And so they're incented to keep things stable and unchanging while the line of business is driving the development team to do things more quickly and rapidly evolve. So this often presents objectives and incentives that are at odds with each other. As you see on the next slide, we believe application delivery via containers represents a best of both worlds approach where these two often competing organizations in terms of incentives and objectives can actually meet in the middle and find that medium that gives them both what they're looking for. Linux containers, as you'll hear from today's presentation, we believe presents fast-changing, agile deployment methodologies for application containers, but at the same time can, when done right, can allow for the operations team to still deliver secure, mission-critical, reliable infrastructure to drive and deliver these applications. So this is the crux of today's challenge, but why we believe application delivery via containers represents an opportunity for them meeting in the middle and in many cases what we refer to as DevOps, and that's a term you've heard quite often and will continue to hear. So let's begin with a little bit of a refresher. What are Linux containers, or what are containers in general? Well, containers are a packaging concept that disaggregates the operating system into two parts. One is a very lightweight, often lightweight, not always, but often a lightweight host operating system optimized to run the containers themselves. But it pulls out of that the core dependencies and runtimes and libraries and puts them into the package of the container. These are the core things required with the application to run, and also represent the stripping of those dependencies away so that the container itself can move from platform to platform more easily. So this helps drive the portability that often is sought in an organization, but it also really isolates those dependencies into the container itself. And then once stood up on a host platform, allows a very nice set of application isolation down through the execution path into the kernel of the operating system, which also brings with it much more efficiencies around the boot times, the performance, and other things as well. And certainly deployment is among them. So this is fundamentally what is a container. So let's start with a little bit of a poll to the audience. So if you don't mind, please take a look here and take the next 30 seconds or so to answer the following question. When do you anticipate that you will deploy containers into production? And you have several answers here. We're just trying to get a sense of you, the audience, as to your level of interest and plans around this technology. I'll just take a few seconds to let the data collect here. So I see an interesting mix here as the data is now stabilizing. We see many of you, nearly 40% of you, who are looking to do something with containers in the next year. We see another group of you who are in a category of don't know. So I think this is a perfect webinar for you to join, because you're going to learn a little bit more, and hopefully at the end of it you'll have a better sense of what your plans might be in terms of this technology. But it's also nice to see that many of you really have definitive plans for it, and we're happy that this webinar will hopefully address some of that. So let's continue on. So recently, Red Hat sponsored a study with Forrester Research, where we asked several hundred prospective, customers and IT organizations of, what are their benefits that they're seeking when they consider container-based applications. And this slide really summarizes some of the core things that they're seeking. Clearly, many are seeking application portability. They're looking to do things faster. They're looking to do things with more flexibility in terms of deployment. And these are at the crux of, many of the benefits that organizations see. So these are the items that were cited as either critically or very important to the respondents. And this report will be available shortly, and you'll be able to download it from Red Hat and see the full report and full analysis from these respondents. So let's start by talking about 6 misconceptions about containers. And now that we've gone through a little bit of the refresher of what the container technology is, in fact, this is the title of today's webinar, and we find that part of the process for grounding people is to really make them realize there are a lot of myths and misconceptions that are out there that are worth going through and talking about, because it's really important to understand sort of some of the boundaries and some of the facts, if you will, about this area. So first, containers are new. That is clearly a misconception. Containers have been around for a very long time. They, in fact, go back to the days of Unix. The Solaris operating system, well over 10 years ago, had a capability inside of it called Solaris Zones that allows you to effectively do things that were container-like. Many of the core technologies that exist inside of Linux to do containers have also been around for 6-8 years. Containerization depends on many different pieces of technology that we will talk about, and many of those pieces have been around for a long time. What we're learning and seeing is that some of the new technologies in the market, like Docker, as a packaging format and as a runtime tool, Docker makes it much easier to build containers, to interact with a container, but fundamentally the pieces behind the Docker tool have been in existence for many years. Containers are not enterprise ready. In fact, we're going to talk about that one in a minute, so I'll hold commentary for that particular one. Third point is the container runs the operating system, and I'll also address that one in a couple of slides. So hold that particular thought. Fourth, containers equal virtualization. The fundamental thing here is that while everyone is writing about containers being the demise of companies like VMware, and containers really mitigating the need for virtualization. We believe these are actually complementary technologies. In fact, there is truth to many of the attributes they bring to the table. They both provide some level of abstraction of resources. Virtualization abstracts hardware, containers abstract the operating system. Both of them also help consolidate applications onto a limited number of host platforms. So there is that level of density and kind of consolidation that's being driven through both of these technologies. But ultimately, they provide very different capabilities for how resources are managed underneath the application, for how the applications are isolated and made secure, and they provide very different capabilities for things like high availability, disaster recovery, and even live migration. So they are fundamentally different technologies, and each of them has their place in the IT organization. Containers are universally portable. I'll also address that later, but I will start by just simply saying when done right, they are portable, but the notion of them being universally portable is a misconception as well. And then finally, security. We'll get into the security discussion a bit later. That's also a misconception. Again, when done right, they are secure, but they're not secure out of the box.
So as Mark has articulated very well, this container technology is not new at all. From early days of even FreeBSD back in the 90s, there was this concept called the gel, and then Solaris, and then Linux LXC. So Solaris containers, all those technologies have been there for many years, and in some cases more than a decade. The fundamental reason is very simple here. Mark has talked about this sort of application portability, the flexibility people need to provision applications, the agility to meet the business demands. None of those requirements are new. I manage the cloud networking products within Cisco, and I've seen customers again, bringing up those sort of agility, the portability requirements for a long time. Now, if anything new, there are certain pieces of the technology that's being standardized or being pushed into more massive sort of the mainstream sort of the kernel or into a more massive market. But on the other hand, containers have been there for a long time. Even just one year ago, last year, there was a report saying that at Google, containers are being spun up and down 2 billion times every week. And keep in mind that that's a data point from a year ago. I'm pretty sure that billing, the number of billings have increased since then. So container technologies are absolutely not new. Not only not new, but also have been proven, have been in production, serving our needs day in and day out for a long time.
Excellent points, Howie. So let's talk a little bit about the notion of the operating system and the container. Again, the myth of the container runs on the operating system. Well, in effect, the myth there is that the container is the operating system. The host is the operating system. The operating system really ends up being leveraged heavily in both places. And if you look at the slide being displayed right now, you'll see pictorially that the traditional operating system has a host operating system with libraries and runtime components, user space tools, all built into what sometimes becomes a very large, heavyweight operating system with many capabilities, many file systems, many tools for performance and tuning, etc., etc. the application runs on top of that. And depending on the application, you may have certain dependencies that are tied to those specific applications. And when you, in fact, want to move that application to a different server, you need to ensure that the new server has the same exact versions, the same exact tools set up on that new server. And that can become a very cumbersome exercise. It can also mean and require new testing be done, but it's a very, very lengthy process often, and typically when new servers are provisioned, that's why it often takes weeks or months to get those set up. In a world of containers, what you heard me talk about earlier was the fact that you're taking the operating system and you're splitting it into two pieces. You're taking the core components required to run containers into the host platform. And that, of course, includes the Linux kernel and certain key capabilities and system services around that. But in the container, you're also pulling the libraries and runtime dependencies that the application needs. And you're coupling that, packaging it together with the application in the container. So therefore, you're able to much more easily move that container from host to host because you're carrying with it, with the application in the container, the things that the application needs. This is a nice division of responsibilities between the applications team and the infrastructure team, because now the developers and the application team, they know when they build out a container and package it, they know what to put, and that's their responsibility to define what's required by the application. So this is how how and why the operating system is really critically important in both places. It's critically important as the host, but it's also critically important as part of the container itself, because that's where the libraries and runtimes and other user space tools get pulled and packaged. And when done right, as we mentioned, you can achieve excellent portability. And we refer to this as the open hybrid cloud at Red Hat, but when done on top of enterprise-grade, consistent platforms built off of Red Hat Enterprise Linux, like, of course, RHEL itself, but also Atomic Host and OpenStack Platform, or running them as guests in the public cloud on Amazon or Google, you can really, truly get portability of the application container across the consistent host platforms. Again, when done right, as well as when done with certified containers, which we're going to talk about shortly. So the other myth we mentioned earlier was that containers are, we said are secure by default, and in fact the myth is that they're not. Containers don't contain. They simply package up the application, but there is the opportunity for malicious content in one container to breach into another. There is the opportunity for malicious content in a container to do damage to the host. Or you need to not only secure the container itself, but you also need to ensure and test it down to the host platform, and really validating that is all secure and certified and of known origin, but also still wrapping those containers with secure technology like SE Linux to get that isolation between the execution path of one container versus another on the same host. Now this picture on the slide is the Japanese home, and we like to use this picture because it is actually very much akin to container-based applications. Japanese homes have dividers. They give the appearance of rooms being isolated from one another. These dividers can be moved, but you're in a room and you think you're in a very isolated environment, but you also can recognize, if you've ever been in a Japanese home, that these walls are paper thin and can easily be opened or broken through. And this is, as I said, like a container metaphor. Containers give the appearance, the application in a container thinks it's the only application on the host, thinks it's the only application on the system, but very likely there's an application sitting just in the next room through a very thin wall, and with an aggressive occupant in one room, they can break through into the other, and that's similar to containers. You know, you put malicious content in one room, they can easily break through into the next one. And that's the metaphor we like to use. And that's why using technology like SE Linux is really important to secure and build protection between those walls and create more true isolation, using labeling and secure labeling between the containers and the applications, therefore providing the security that you really, really need. Another example of security has to do with the container content. You know, recently we looked at MongoDB and did a search for the MongoDB images on Docker Hub using the Docker pull command from Docker at the command line. And what you find is that there are hundreds and hundreds of MongoDB images that are resident inside of Docker Hub. And it raises the question, you know, what's the difference between these images? Who built them? You know, were they, you know, why were they put there? How old are they? Are they safe? Who's maintaining them? You know, all of the pieces, you know, what platform does it actually run on? What version of the Linux kernel? What user space tools does it need? Things like that. So this is an example of, you know, why understanding the origin, the security, the trust and provenance of the container itself is very, very important. And between testing, validating the container itself and ensuring that it's been certified, but also going further to, as I've discussed, put security wrappers around the container with SE Linux, you end up with the metaphor now shown on the slide, which is the vault. You know, very secure environment, controlled access, hardened, and safe and trusted. So this is the real metaphor for, you know, out of the box, containers not secure, but when done right and done carefully, they can be made very, very secure. So now that we've gone through the misconceptions and hopefully addressed for all of you those misconceptions and giving you some insights into, you know, what the truth and what the facts are, we're going to change gears, and we're going to now move into, you know, what we believe companies need to implement a container-based application architecture. And in fact, we've talked about some of this as we've dispelled some of the misconceptions, but let's also go a little deeper here. So laid out on this slide are 5 key things that we believe are important: a trusted operating system, security, certification of the container contents, infrastructure that you can trust and rely on, and then, of course, in many cases, because these are running in cloud environments, either private or public clouds, you need a cloud that you can also trust and depend on. Starting with the operating system itself, you know, we announced about 2 months ago, in fact 2 months ago to the day, Red Hat Enterprise Linux Atomic Host generally available. And this is our version of an optimized host platform to run containers. The important thing for you to realize here is that it is built and derived from Red Hat Enterprise Linux, you know, a mission-critical operating system that has 13 years in the market and now a commanding leadership position in the market. It's built a massive hardware ecosystem. It's also built up a strong ISV ecosystem, but ultimately it's depended upon by many companies to run their mission-critical applications. RHEL Atomic Host is a direct descendant and derivative of the key pieces of RHEL. And in this case, RHEL Atomic Host is a derivative of RHEL 7, but uses the same Linux kernel, the same version of C groups, SE Linux, systemd, and a variety of other key capabilities. In the way it's been packaged is it's a minimal footprint operating system. So it is optimized, lightweight to run containers. It is therefore more portable, more easy to deploy, has a reduced attack surface, and also allows you to orchestrate these at scale. The next slide talks about securing the host, and I've talked about this quite a bit. This, the important thing here is, as I mentioned with the MongoDB example, you need to understand what's in the container, what application exists, what are the libraries, what are the user space tools that have been packaged up into that container, and are they from trusted sources? Fundamentally, do they also run on a host platform that you can depend on, and has it been validated and certified against that host platform? We are embarking on a process, also part of an announcement about 2 months ago, where we're unveiling capabilities for our ISV partners to build certified containers, certified by Red Hat, and also where they're placed and put so that consumers can get them from trusted sources. And then the slide you're seeing now talks about where they come from. We unveiled Red Hat Connect for Technology Partners, which is the way that the ISVs will engage with us. And through this, they get access to tools like the Container Development Kit to build containers. They have the ability to then certify the container contents and against the host platform, and ultimately put those into the Red Hat Container Registry, where it becomes the known trusted source for those containers. The need for standards is also critically important. Standards cuts across many, many different areas, and of course we've been doing standards and driving standards for years, and it is important because customers need standards to ensure that their investments are protected and to streamline the way they use the technology and allow for reuse. Ultimately, there are capabilities inside of Linux that drive the standards for containers. These include things like C groups, systemd, the Linux kernel, having standard tools that drive containerization. The Docker tool also fits into this category. Spilling into Docker, though, the container format itself is also a standard that we're embracing around the Docker format, and believe that a singular standard for the format of the container drives reuse, portability, and much better proliferation of this technology into the customer. How those containers are orchestrated at scale across clusters of hosts is important, in doing that with a standard like Kubernetes, which is Google's the lead on this project, and we are the #2 contributor behind Google. That's another important standard. And then finally, how these are put into the registries I've mentioned, but made in a way that they're discoverable, that they're indexed, that they have metadata, and that that these are all standards that allow the federation of multiple registries, security models, access, etc., around secure standards for the registries themselves. The other thing that we think is really important is the integrated application delivery platform. And this here goes well beyond the container. It goes beyond the container because the container is important, but the host that the container runs on, as I've described, is also critically important. The infrastructure like storage fabric that services and feeds the container infrastructure is also important. The containers themselves, being content that's from trusted sources and certified as I described, is important. Orchestrated consistently across clusters of hosts, and then the tools to deploy, scale those containers, and also to manage the container content, the host content, and then the container lifecycle. These are all the important aspects of why it's much more than the container. It's even much more than the host. It goes into the full continuum of an integrated application delivery platform. And Red Hat has many of these pieces available today, and is moving quickly ahead with our management products like CloudForms and Satellite to bring to bear the necessary components to manage the container content and the lifecycle of the containers itself. I'm going to turn it over to Howie Zhu now to carry us through the next set of slides.
Thanks, Mark. Mark actually just articulated a very one of the most important points of this presentation, which is about container technology is not new. It has this and that attributes, but really what's most important part for this technology to be used in a successful way is to look at the life cycle, entire life cycle. It's not just a container technology, how many containers you have, but also the how you manage it. What's the visibility? What's the networking? What's the server? What's the entire ecosystem around the containers? That's really going to set container technology adoption apart if we do it right. Because what's important here is customers not only look at a container, but also the entire life cycle management of the server workloads or the some critical infrastructure. So here, I'm going to talk about the three elements within that lifecycle management, within that ecosystem. It's not the only three things that's most important. It's just the three of the things that's sort of, Cisco is very strong in it. And then also, we have a lot to talk about in terms of what we have today. So let's get on to the application-centric infrastructure first. The ACI is a technology that Cisco has rolled out in the last couple of years, since about a year ago. And then the idea here is very simple. You have people who understand the networking technologies inside out, like, what is the echo policy, what is the QoS policy, what is the isolation, VLAN, PVLAN, those networking jargon. And then you have people who understand the application requirements and understand the jargons on that side. What is my availability? What is the uptime? What is the sort of the isolation policies? HR servers cannot talk to the engineering servers. Things like that. So you have two camps of people who speak two different languages and then who sort of have very different skill sets. But in today's environment, as Mark pointed out, people wanted to deploy applications fast. The turnaround time between, for the negotiation between application guys, infrastructure guys, and the networking guys, used to be okay maybe in a typical enterprise, but people are getting less and less patient. So the idea of ACI is to translate from those application language or application requirements into the networking language automatically, consistently, for virtual environment, for physical, the bare metal environment, for everything, in automatic, in a pervasive way. So that's the idea of ACI. Now, in the context of a container, that's super important because if anything, containers bring to the table is the higher demand in speed, in efficiency, more containers, more workloads on the server. People have even less patience because, maybe it's okay for me to spin up and spin down a virtual machine in a few minutes, but here I want it to be done in a split second. So those kind of the automatic translation, the breaking down the silos, and then do things in a more sort of policy-based driven way is even more important in the container land. So ACI was sort of the invented for virtualized environment, virtualized data center, bare metal, and right around the same time, container technology got a lot more momentum, and then so from that point of view, we actually took steps, and then getting the container technology into ACI, the infrastructure, the product line as well. For instance, the brand of the ACI infrastructure is APIC, the application, the application the controller, and we wanted to be able to drive those plugins onto those Linux hosts, so that the policies can be pushed down to each of the containers in a relatively fast and precise, descriptive fashion. So that's sort of the one thing Cisco has been doing with containers on this on our key initiative, the application-centric containers. This is some of the details in how we do the container plugins, and basically we actually have a open source project called Contiv, C-O-N-T-I-V, and then it's actually being made to public. And then the idea here is we do a lot of the Linux, the plumbing side of work, so that the networking policies can be pushed at a granularity at a container level. So when Mark talks about how to set container deployment to be successful and how to make the containers to be secure, he made it very clear that container itself may or may not be secure, depends on how you utilize it. When you have container technology and you have the ACI, for instance, ACI plugin technology, so that you can actually isolate or give very specific security layer 4 to 7 policies to each of the containers. Then container usage can be a lot more secure, a lot more with ease of mind. So that's how we, Cisco, looking at to sort of complement the container technologies, a platform, for instance, Red Hat has, so that we come together and then deliver a holistic solution. So that's one example of the container technology ecosystem element. The second one is Intercloud. Mark said at the very beginning of the presentation, the key problem statement the container technology is addressing. You have IT guys in the middle. On one hand, people want to do things fast, want to move things into the cloud, want to just port the application left and right to different clouds, to different data centers. But on the other hand, you have guys, whether security guys or infrastructure guys, basically saying that, look, slow down. Let me make sure that you still, whatever the workload, whether that's container or not, still enjoy the same compliance, the security. How do we make sure of that? So you have this constant struggle between people who wanted to do things fast and then utilize whatever the resource out there, public cloud, private cloud, and the guys who says, wait a second, my current practice, my current technology is not going to allow you to move things that fast. So, and the container technology will help to ease that because of the standardization of the format, the lightweightness, so that it gives that benefit. So where we are, at Cisco, we are contributing here is we have this initiative or product called Intercloud. The vision is simple. You allow the workloads, maybe that's a virtual machine, but in this case, it can very well be a container to move around between on-prem to off-prem, or between one public cloud to another public cloud, while retaining the same policies. You get consistent policies, security policies, compliance policies, and you still have the control. You know what's going on. You know, okay, I have moved 2,000 containers from this cloud to that cloud, and the security policies are kept the same. And yet you also have the choice. You have the choice of going through different clouds, whether that's Amazon cloud or AWS clouds. So you have this sort of policy consistency. You have the compliance. You have control, full visibility. Yet you have the choice of moving the workloads around. So that vision will actually address the very problem statement that Mark has been talking about through the presentation, which is a problem statement that people are having today. How to struggle between the struggle between the agility and the security. Someone wants to be slow and someone wants to go faster, and the marriage between container and the intercloud technology will go a long way. For instance, this is an example of the Intercloud Fabric container support. On the left-hand side, it's an on-prem data center, and on the right-hand side, it's a public cloud data center. And as you can see that we allow the virtual machine to move, and then while keeping the same policies, security or whatnot. And the same thing with containers. And a better yet, sometimes we allow people to move from a virtual machine, and then we actually convert the form factor into a container, so that you enjoy the benefits that Mark has been talking about in terms of the flexibility, portability, application agility. So that's the sort of the vision and then the goal of the Intercloud, the Cisco's Intercloud Fabric, which is to sort of get a vision of the benefits of the containers into a real world usage. In this particular case, it's about porting applications among different clouds. So that's the second example of how we can complement the container technology and contributing to this ecosystem. And the last but not least, whichever operating system, whether container or virtualization, at the end of the day, you have to run it on somewhere, on a physical server. And a Cisco's UCS system is a system that sort of from the beginning of its design, it's very much just policy driven. I talked to lots of customers. People said, hey, how come, UCS went from nowhere just, not too many years ago, and invented, and now it's actually taking it's the number one in the U.S. blade market in just a few years. Why is that? And why, 85% of Fortune 500 companies use UCS? At the end of the day, it's actually the flexibility, the policy driven. Because before you sort of provision a physical server, and you say here's a Linux, here's whether Solaris, or here's this and that. It's sort of you marry the identity, the workloads or the operating system to the physical server. Once you change things on top of it, you have to do a lot of the rewiring. You have to do the identity is different. Now, the change of the identity, change of the application, change of the workload is just a matter of mouse click. You just one policy away, you change the entire thing on top of it. What's very important, relevant for this discussion is containers is all about come and go, right? It's very ephemeral. If you look at the recent data center technology in the last 10 plus years, one of the big change is went from the sort of the very stagnant, the top to bottom integrated service into quite ephemeral, lots of different microservices stitching together. The demand for spinning things up and down is actually very high. So as a result, you want server technology to be on the same wavelength. You don't want, the application layer, the operating system, Red Hat, it's a very flexible operating system. Yet when it comes down to the physical server technology, it's in the way. So now you finally have a server technology that's in the same wavelength as the software, because fundamentally the differentiation of this UCS is the software side. So as I put it here, it's wire once, and then but it's future-proof, so that you don't have to worry about getting married between physical provisioning and then what's running on top of it, too much, because it's everything can be sort of the provisioned with one policy away. So that's the sort of the net of a few things, a few examples how Cisco's technologies can complement the container technologies, and together with Red Hat, the operating system, together, you have a entire ecosystem working for you to get you to be successful in this onto this container journey. With that, I wanted to do another polling question. whether based on this talk or based on your understanding, based on your own sort of environment, what do you see? What are the primary benefits you see in your environment with using containers? So the feedback is coming in. It's pretty interesting. It's actually quite across the board. There is no obvious winner and the loser yet. We will see. Very nice. So so right now we are seeing that hundreds of people have voted, and the one, it's not quite a winner taking all kind of thing, but at least a relatively winner is to reduce the effort to deploy application. So that's very much what Mark said. The agility, the flexibility to deploy the applications. At the end of the day, we build infrastructure for applications. Infrastructure, container, data center, they are all means to an end. The end is the applications. So good to see that. But it's also good to see that actually people see very diverse benefits of containers. It's not just one thing. It's a lot of different things. So sounds like there is a pent-up demand to get people into this technology. So with that, I'm handing over to Kimberly for Q&A session. We have about 12 minutes for Q&A.
Thanks, Howie, and thanks again to all of you who are joining us today. We will now answer as many questions as we have time for, and you can submit a question by entering it into the Q&A panel in the lower right-hand corner of your screen. We already have a lot of questions queued up, and I've seen several questions around performance and containers. So Mark and Howie, maybe Mark, you could take a stab at this first, and Howie, you can join in. But how does containerizing an application affect its performance?
Thanks, Kimberly. Yeah, we've done a lot of testing in our labs at Red Hat, and the fundamental benefits are around the boot time. So the boot time, because of an optimized host for containers like RHEL Atomic Host, very, very lightweight, an order of magnitude smaller than the full operating system. The boot times are significantly faster. And then that, of course, also allows you to replicate and scale those hosts, across virtual infrastructure very, very, very easily. So we see a benefit there in the container itself, and the application in the container being also very lightweight, also boots quite quickly. But we've seen no performance degradation at all of using this technology when compared to running, say, an application on a bare metal server versus an application in the container on the atomic host. Performance is almost immeasurable. Performance differences almost immeasurable.
Yeah.
Great.
In terms of performance, there are different levels of performance, right? There is just running the workload by itself, and then the impact. I think there is one question about the impact of running different workloads or containers on the same OS and on the same host. Is there any performance impact? For most part, that's actually the beauty of the container technologies, which is the resource management, the isolation of these, the performance impact. Because we count the CPU, the disk, to do the right the billing of each of the containers, so that they don't impact each other when it comes to there is a busy container, and then it will have very little or no impact to the rest of the containers on the same host.
Thank you both. This question looks like it would be most applicable to Howie. Are the cloud islands built on the same hardware stack and separated by containers? How does that work?
The cloud islands built on the same hardware stack. Okay, so first of all, at this point there are lots of stack. So to say that there is the same hardware stack among different clouds, that just cannot be true. Now, there are clouds out there who are supporting the containers primitives better than other clouds. Yes, that's true. In general, container technology, as Mark said, and it's not new. However, when it comes to public cloud offering as a sort of a consumable, let's say REST API for people to spin up and down the containers in a public cloud fashion, it's still at the beginning. A lot of the container technology in production for a long time is for internal cloud consumption. Like for instance, Google has been using cloud forever, but that's a sort of internal technology. So so it really depends on what cloud you are talking about. The answer varies.
Thank you. This seems to be an applicable follow-up question. In terms of from a infrastructure perspective, perhaps I'll let you both fight over this one. Does it make sense to run containers in a virtual machine in the cloud?
So I think for just like many questions already coming into the queue, the answer is the same. It depends. But let me elaborate why I said that. So container technology, in many ways, it's truly dear to my heart because my background, early days was server virtualization. I was one of the first engineers at a server virtualization in the server virtualization industry back in the days at VMware. That's many years ago. And the reason I got into virtualization at the first place is I saw, wow, here is a technology that makes things a lot more sort of the the physical land is so clumsy and then so slow, so inefficient. And now here's a virtualization technology that sort of makes things so fast, so efficient. Now, when I look at a container technology, it's the same, many years later, compared to virtualization, the virtual machine technology. Virtual machine, as Mark said, the boot time can be very different. Sometimes it takes a minute to boot a VM, but, it may take a split second to boot a container. That's a huge difference, right? And efficiency, how many containers can you run on the host versus how many virtual machines you can run? It can be order of magnitude difference, in some cases. So clearly, sometimes when you think about this, container technology is such a no-brainer. And when you try to marry container and a virtual machine, like running containers within a virtual machine, it started making less sense because you get a benefit for running containers, but within a VM, you lose a lot of the benefits. At the same time, sometimes you need a very secure, security primitives, the guarantee that you need from virtual machine. That today you don't have that, at least not yet from containers alone. I mean, like Mark said, if you sort of do some, secure Linux, doing X and Y, Z, sometimes you can achieve similar purposes. But then people need, still need a virtual machine sort of the requirements, that the virtual machine kind of the capabilities to fulfill their requirements. So in some cases, running containers, makes sense. So sometimes as a stopgap measure, you get some benefits of containers, and then you sort of you get the good part of the both worlds. But then sometimes you just run it in the virtual machine for the time being, and then over the time when the sort of the Red Hat, the bare metal OS, gives you the same benefit, you feel like, well, why do I run it on virtual machine? Then you get out of that. So I can see a very wide spectrum of the usage, from all the way to just the containers, no virtual machine, to all of my containers running inside a virtual machine, to somewhere in the middle, and then with some migration path or not, with a deploy migration path to get out of the virtual machine over the next 2 years. There's a wide spectrum I can see, and then they can all be legitimate use cases.
Yeah, and I'll add just a quick thing to what Howie said. I think the correct answer is it depends. When you're introducing a virtual machine, you're going to obviously run it on top of a hypervisor, and sometimes that's beneficial because of security or resource isolation that you really want. But there are other times when that may introduce a level of management or performance overhead that you just don't need. So it really does depend on the particular application architecture.
Thank you, Mark and Howie. Okay, I'm also seeing a lot of questions around orchestration capabilities. How do you make different containers talk with each other, and how do they communicate with each other? Mark, I think I'll throw this question over to you.
Sure, thanks, Kimberly. So, it's something we didn't touch on very much in today's presentation, but one of the key things we see customers starting to explore is the ability to take containers and implement a distributed composite application fabric, also sometimes referred to as microservices, but using containers as a way to disaggregate a typically monolithic large application into sets of discrete components and functionality that are comprised of multiple containers. This allows more flexibility for updating pieces of the application. It allows for more flexibility to implement load balancing of parts of that application, let's say like a web front end part of it. It allows you to also do things like disaster tolerance or high availability implementation for only core pieces of the application instead of for the whole thing. So it unveils a lot of flexibility to how the application is built. But the but is when you do this, you're now unveiling a set of complexity for how that application is tied together and stitched together. I use the word composite application fabric for a reason, because it is a fabric that needs to get knit together. And how that happens, is very critical. That needs to happen. There's a few pieces to illuminate there. One is the containers themselves. They need to be described by standards and how you interact with the container, the metadata for the container. All of this is part of the container format like Docker provides. The second piece of this is how those are all tied together and orchestrated. Because I alluded to things like high availability, load balancing. Those have to be done often across multiple host platforms, and that orchestration is very, very complex. And so that the bet that Red Hat is placing is with Kubernetes. I mentioned that earlier. It's a project started by Google about 10 months ago. We are the #2 contributor to Kubernetes behind Google themselves. It's a standard that has gotten wide acceptance by companies like IBM and Microsoft and Red Hat, and of course Google. And Google uses, this is a derivative of Google's prod engine environment, also I think referred to as Borg, where Borg created the ways in which to orchestrate the millions of containers together in the forms of things like search and Gmail and other things they do. So this orchestration is critical, but it also depends on the metadata and the standard for the container themselves. So these are some thoughts about how these containers are tied together, how they're integrated, ultimately getting into microservices and this composite application fabric that I described.
Thank you, Mark.
And as I mentioned earlier, orchestration, it stitch a lot of things together, networking, server, storage, you name it. So that's where, a lot of the ecosystem, picture comes into play here.
Great. So, Howie, you mentioned this earlier, but I'd like, I received several questions around the differences between Linux containers and Solaris containers or Solaris zones. Can you expand on the differences there for folks who are familiar with Solaris zones?
Well, so the gist of the technology is the same, right? Because when it comes to what is a container, as Mark said, you bring the library dependencies out of the operating system and then attach to each of the applications. You get a portability. But how do you define, this thing? It needs to be standardized. Docker, actually paves the way for that standardization. That's why there is a lot of buzz around this new thing. The container itself is not new, but the standardization, the sort of the agreement to this is relatively new. So, if anything, sort of the difference, it's the sort of the, on one hand, the technology-wise, maybe minor difference, minor details, but those minor details matters, right? Because, when everyone agrees to something, then it can be really a lot more portable, But the core part of the technology when it comes to resource management, the billing of the CPU cycles for each containers, the storage or the networking, a lot of that is very similar, at least in concept.
Thank you. We are at the top of the hour, so I think that let's wrap it up with one more question here. And for those of you who did not get their questions answered, we have quite a few here in the queue still. What we'll be doing is following up with answers to these questions at a later time. So the final question, I've seen this from several folks here, and let me try and summarize a couple of questions. Are containers production ready now? And what are your customers doing with containers? Let me open that up to both of you.
Sure, I'll take it very quickly since we are at the top of the hour, Kimberly. I think the slide that Howie talked about is a couple of great proof points. I mentioned Google. Google's doing 2 billion containers a week through their infrastructure. They've been doing this for years, and they run Gmail and search this way. It's all architected, orchestrated, built off of container technology. So that's clearly a level of scale and enterprise grade that I think would answer the question of yes, it is enterprise ready. OpenShift, which is our platform as a service offering, has been built on containers for 4 years, and its underlying architecture is also done the same way. We're in version 2 of OpenShift. Version 3 is in beta and will be GAing later this year. And OpenShift 3 will use Docker, will use RHEL 7 as the core, will use Kubernetes for orchestration. So it actually it's been doing containers for 4 years, but it'll even take a step toward modernizing the architecture around containers with the version 3 coming out later this year.
So, there are a few, like Kimberly said, that there are a few related questions, I saw here. Like, is there anything that cannot be containerized? Why would we trust the containers? I mean, it's the same thing in that, the answer is the same in that I view container as a journey. And as I mentioned to you that, I was with the server virtualization journey from the beginning. I saw firsthand that, of course, at the beginning, people don't trust it. People don't necessarily put a lot of the important workloads on server virtualization. Over the time, the technology got matured, and then, people put more trust and more, important workloads on it. And with container, I anticipate the same thing. The technology benefit is no-brainer, right? How portable things are, how flexible things are, how how much agility you can give to the applications. However, it will take time for people people to start trusting it. Maybe you shouldn't trust containers today, given the requirements you have in your environment, and maybe you should give a try with some test deving, workloads first, and then build up, trust. And also, as Mark said, it's the entire orchestration, the ecosystem, the whole thing around it, the certification, and it's a journey. It's a journey that's going to change the industry big time. I have no doubt about it. But it will take time for this technology to mature. It is already mature for when you look at it from certain lens. Google has been using it for 10 years, more than 10 years in production, no question about it. But it's less mature when you have other requirements added to the picture. So it's really different lens. When you look at it, you get different maturity score, and it's a journey for the next few years for this technology to take off. We are both very excited about this technology from both Red Hat and Cisco's perspective. We are looking forward to taking you together onto this journey.
Thank you, Mark and Howie, and again, thank you all for attending. As I mentioned, we will be following up on the questions that we did not get to during this session, and the webinar is going to be made available on demand after this session so that you can direct others to watch it if you choose to do so.
Thank you, everyone.
Thanks, everyone, as well. Thank you, Kimberly.
Thank you.